I've had this Kubota excavator, I don't know, maybe 3 years now, something like that, and I just love it. I am in love with it. I don't think I'll ever be able to get along without it. It weighs about 10,000 pounds, and it's agile, and it's mobile, and it's handy. But I'll tell you what, in Oregon we've got a lot of stumps, and stumps have to be pulled and dug out, and a 10,000 pound excavator just almost won't do it with a bucket. But with a ripping tooth that concentrates the full breakout force on just, 1 square inch at a time, you get a hold of something and start pulling, and you're probably going to move it. So this video is a how-to, what it took for me to get this built, pretty good overview, and then we will have the same video in depth in the Essential Craftsman Academy, including the drawings, a PDF, all of the CAD drawings and everything you would need to be able to build one of these yourself if you need to. So the advantages of a ripping tooth are not just that you can rip stuff, but that you don't have to dig up more dirt than you need to. It plunges into the grade and it severs and it tears and it breaks things that ordinarily would have to be dug out and make a big old excavation and clean up a big old mess when you're done. Nate says this looks like a perfectly designed tool for breaking natural gas lines, but the first step of design, for me, design build processes, is more often than not a full-size pattern or template made out of wood. Now when I'm fabricating, that gradually transitions to a hybrid template made out of wood and steel, gradually morphing more and more to the steel. All right, the rough template's pretty well cut out on the tooth. The ripper itself. Down here at the bottom, it's going to receive a rock tooth. So that's the factory-made receiver for the rock tooth that'll go on right here. It'll weld in. These are more or less the curves that come up. This is going to fill in right here, so it comes up kind of just outside of that, welds into the plate that I've got cut out to go right there. I'm going to either grind or cut some little teeth on there so that when you're pinching a log or a branch or a piece of firewood or a root, you can have a little bit of friction in there and not just the squeeze. So anyhow, I'm going to lay this out one more time, cut it a little cleaner, sand it real nice so that they can get their points for their CNC cutter right off the wood itself, just like they did off of this top piece. Not exactly machine work, but I think it's going to be okay. All right, gonna have Brian come out here. Two of us will manhandle this up underneath the boom, lock it in, and just evaluate whether or not this thing is the right attitude, so it'll reach far enough and curl back far enough. Make sure that this thing is gonna go up here like that. And then we'll get her cut out of some 3/4 inch T1 over at North Star Fabrication. Weld this thing up. So I'll get in and I'll pull this bar back, okay, and push it up. Okay, go ahead. Yep. No bind, no tear, no growl?
Nope. No, went right in.
Okay.
stick towards you some more.
Okay.
Now curl out. Okay, right there. That's a perfect angle for trying to peck at a rock or rip it right there.
Let's see how much further out it'll go. Okay, not, all right, that's
Okay.
not terrible, right?
Yep.
It gets maximum extension. It's
Stop right there.
It's in line with the boom.
Okay. Curl it down.
Coming in, okay.
Like you'd be down in a ditch. Okay. I think it's right. I think it's the right angle.
Did the thumb bind on the edge of that plate?
No, but it will. Go ahead and go down. Oh, right there.
You gotta eat that plate out?
Yes. Yeah, because that limits you to like an 18-inch log.
Okay.
I think this will be fine.
So I thought I could just cut off the end of the base plate with a hot saw and fix the geometry of the thumb movement. But it was a waste of time. I ended up having to knock the ears off of the base plates and then torch the extra material off the ends of those ears that I had included in my template. I thought I was doing a good thing. I wasn't. Lesson learned. Well, the geometry was not quite right on my prototype. I had them cut out just... Anyway, it's not quite right, and I've got to cut loose the tacks. Going to use this cut-off wheel. It's worn down. I hope it's projecting far enough to get into the meat. We shall see. Going to try to protect my face because you guys have convinced me in the comments that these things are lethally dangerous. So, got to at least put a full face shield on, I believe. So, fingers crossed. Moving forward. Second prototype probably is going to work. So I have a tendency to overthink. You've probably picked up on that, and sometimes overcomplicate, but sometimes save the day too, right? I mean, visualizing problems. So that's the template. I'm probably repeating myself that I made off the buckets, but I modified it a little bit when I took it down to the CNC plasma people in order to create this straight bearing condition to coincide with the plate. And I extended this thinking that I wanted to bring everything forward. Well, that's where the geometry broke down and the engineers had it right, and so that's why I'm modifying these plates by cutting off what sticks out too close to the thumb. I've got 2 plates cut out. I'm going to burn the boats and cut 2 more, and then we'll tack together the second prototype to see if it works. Critical dimensions. Yes. See how that coincides with this. Yeah, this is the one I should use. Very good. Critical dimensions. Fit is good. Well, every once in a while things work out, right? And the rule is when you're cutting something off, if it drops, you won. And that dropped, and so I won kind of. That's not a beautiful cut, but it is what it is. Wide open to your suggestions. The comments are where the education happens, so fill us in, will you? 20 pounds oxygen, why? 7 pounds acetylene, why? How fast do you feed? All those things, because a lot of you guys are real fabricators, and so you've got things to say, and we all read the comments, so help us out a little bit, will you? All right, I've been battling geometry a little bit, but I think that that's going to provide the gription that we've got to have to match the gription on the thumb. We'll be able to slide the rock point in here I think it gives the right angle. Brian's going to be here in about 2 hours. I'll have this thing set up. We can look it over. One man on the ground, one man moving it around, and just make sure that this is what we want both of the rippers to look like. So the adage, jack of all trades, master of none, is sometimes better than a master of one, is holding true for me here today, because I'm just sort of a half-baked fabricator. I can weld okay, I know some of the tricks, but the fact that I'm a carpenter is an advantage, because with a miter box close by, sliding compound miter saw, I can cut wooden spacers more accurately, quicker than I can do it out of steel, right? I mean, I can cut right down to pretty much perfect for square down there in that direction, and then about a 1/16 of an inch wider up here than it is down there. And my friend Mike Smith told me to do that because I'll weld the outsides of these things first and then weld the insides. And he pointed out that welding the inside second is going to tend to bow that in, kind of crowd the inside together. So he says if I give it an extra 1/16 up here, by the time it crowds and rolls and flexes these things towards the middle, I'll probably be just about right. Problem is, this attachment's kind of heavy, and it's got to slide down into this cradle, right? And then I've got to hold it back up against the foot, get in the cab, manipulate the lock, but I have an idea. In the same way that sometimes you can put a man out of work with a nail, sometimes you can put a man out of work with a rope. I hope. So the idea is, to unlock this, I have to retract this keeper and then pull the attachment into the lock and then let go of the stop on the keeper so it shoots back in there. Let's see if we can record that. Let's see what we have here. Yes, it's in. Sometimes it's the simple tools that make the complicated tools work. So here's that bar, that round bar that gets trapped between that retractable keeper and the world. There's the fit up. There's the fit up. All right, the saddles are ready. They fit. I think they're going to work. So I'm going to go over to Jim Denny's, take my templates over to North Star Fabrication. Jim and Jack own that outfit. They've got a big CNC plasma cutter. And when I bring those hooks back, the actual ripper teeth, I'll weld everything together all at one shot. I'm over at North Star Fabrication. I've been here before. You watched them bending some big pieces of plate at temperature. They've got a big anvil over here. Jim Denny, James Denny, and my brother-in-law Jack Trowbridge own this outfit. They do a lot of interesting things over here, and today they're going to cut out the hooks for my rippers. Isaiah, nice to meet you.
Nice to meet you.
How did you get connected with Jim and Jack and the boys over here at North Star?
Yeah, that was actually my brother David down there.
Oh, that's your brother?
Yeah.
No kidding. The old left-right punch here, right? 1-2 punch in the plasma department.
Very true. At one point we had 5 brothers total working here.
Serious?
Yeah.
Now, in the same way that the design sequence for me in my shop went from wood to steel, here at North Star Fabrication, the design process went from wood to photograph to digital files to steel. Isaiah is the digital drafting and software tech, and his brother-in-law, David, understands and runs the really big CNC plasma cutting table that actually does the production work itself. I think it is the biggest CNC cutter in this part of Oregon. Both of these guys are intelligent, hardworking, young Christian men, and it does my heart good to connect with young guys like this. Just like that. Nice usage of the rim. These guys do so much work over here that the chance of them having just what you need is pretty darn good. Wow. So how much heat soak? How far in is that hot? How hot is it?
It's warm all the way to the center.
Let me see. Oh, not bad for what just happened, though.
No.
What is that? Maybe 150 degrees right there, 140 degrees, something?
It get a lot hotter up on the ends there.
Oh, yeah, where it's smaller.
Yes, sir.
So Roland Guthrie, you've seen him helping me on the gate. Whereas I'm a shade tree welder, you know, a farm welder, you know, a carpenter welder. This guy's a real welder. And I had him come over today to make sure that I'm implementing the process he described to me about right. Now I've talked to two or three guys who are real welders, and they're all telling me about the same thing. And in a multitude of counselors, there is safety, right? So he's showing me how to use, he wanted me to get 5P plus.
Yeah.
Instead, I came home with straight 60-10. So we're just practicing with the amperage on my little Fronius welder, because I want to burn the root pass in. He tells me that no matter what you do on top of it, if the root pass is not right, it's not right. Is that right?
Correct.
Yeah, all right. So we're down to 110 amps on the Fronius. It's going to be controllable. The arc force is really strong. That's what 60-10 does, big arc force, right?
And you can dial in, I don't know about that machine, but some machines you can dial in your arc force.
Oh, can you?
It digs harder.
Really?
Yeah.
The machine will make the rod
Yeah.
push harder, not just hotter.
Yeah.
Wow. But that's the setting we're going with. Such a smooth little welder, doesn't weigh much, works great. And I've got a whole bunch to burn right here. I'm going to put root passes on both sides of both of these saddles, and then covered up with 70-18, right?
Right.
1/8 inch.
It would be faster and easier to run 532 or maybe even 3/16, but if what you've got is 1/8 inch, we'll do multiple passes.
And I'm not sure that this would 100 and what did this go up to, 120?
I forgot about the machine. It will certainly do 120. We already did that.
And 120 is plenty for 1/8 inch, 70-18?
Yeah.
Okay.
Yeah, plenty.
Well,
it's hot.
we'll go like that then.
Yeah.
All right, thanks Roland. Give me a little more coaching and we'll make something happen. Okay. There is nothing like having someone who knows what they're doing point out to you what you're doing wrong. There's nothing like it. Does it feel good to realize that let me see, I learned to weld when I was 16 years old in high school, and I've done it off and on ever since, and I've always had it too hot and kept my arc too long. And the arc kind of swings back and forth, and it's pushing hard, and it's undercutting on the top and the bottom. Even 70-18, I always had too much power and too long an arc. So I'm getting the feel of it. I'm going to show you these, and I'll show you the ones I do after. So those stringers, there's nothing magic about running 70-18 stringers, but that's better than I've done in the past. And I think that by the time I weld this one off, I might even show you the beads I get with the 60-10. All right, next item is to weld this tooth holder. This receives the tooth, the rock tooth that's going to go on there. That's the wear item. I don't want to wear away the ends of these rippers. I don't want to wear away the holder. So you put the holder in it, tack it, and then preheat. So I did not get a great fit up on my pattern. Can you see that? I got, a strong 1/8 of an inch gap, but I think I can fill that or bridge it. The rest of it's pretty good. Gonna run a 60-10 bead around there now that Roland has shown me how to do it better than I have in the past. All right, I think I'm going to tack this on here, check it for square, and then start alternating passes with the 60-10. I've gotten conflicting stories on whether or not I should preheat this, and in general, preheating something this size is good, but I think I'm going to count on the root pass with the 60-10 to preheat enough that it'll drive the water out so that the low hydrogen 7018 does its good work. This one's mine, the other one's Brian's. I might preheat his and just see what the difference is. All right, I think that's gonna line up. I wanna be able to rock that down in there without breaking off the 4 tacks I have holding that hook onto that saddle. Touchy. All right, we're pleased with the geometry. I'm gonna get away from this thing, put it back on that little sawhorse and weld her off. Well, it's bright and early, 5 a.m. It was time to get up and come out and start welding before it gets hot. And we're all prepped up, ready to go. These things are braced into place, nice and square. The trick is going to be keeping them square as the stringers go in on this long line and tend to pull it back and forth. We're going to monitor that, play with it, weld this thing off, and get ready to put it to work. .7018, 1/8 inch, and as I've mentioned, a much shorter arc at 110 amps. Well, I've been anticipating that after burning 6 or 7 pounds up here, that I would be doing better when I was welding this tooth onto the saddle, right? But man, I had it down on that little sawhorse sitting on those low chairs, and it was awful. So I've got it up here on the bench now. I'm feeling a little better about my life choices. And sure enough, the beads are releasing the slag, which is an indication that you're at least fairly smooth. That's a way better bead. And what this does is reinforce my profound admiration for you pipeline welders that are always out of position, never working at a bench. I don't know how you do it. But we're just going to keep burning rod and maybe we'll make progress. Good thing I'm not taking that to the fair. But once I got into a better position, I ran out of excuses. And the other side maybe is a little better. It almost looks like a welder did that, but not a good welder. But I think it's plenty strong. It's 1 1/8 across the face of that fillet. You know, 5/8 up on one side and 3/4 over on the other. Should be strong. I've got some gussets to put on here, so I'll put my carpenter hat on for a few minutes, make some templates, you know, transfer the marks, cut it out of steel and weld it in. Almost home. Well, I've had just about enough fun stick welding, even though it is fun, and I feel the skills growing. I'm going to weld this with my MIG gun because I'm fighting time. I've got to have this over to Nate's in 2 hours, ready to rip out a stump. And so I'm just going to MIG it 035 wire up towards the top of the range, feeding the gas pretty hard. Let's see how we do. I think we have a launch. I didn't get these braces in here quite symmetric, but I'm going to give this one to Brian, and I'm going to take it over to Nate's right now and see if it'll rip out a pretty good sized oak stump. Fingers crossed, steel's still hot. Now, if you need to build one of these ripper teeth, if you've thought about it, if you're a fabricator or you know a fabricator, our Essential Craftsman Academy, that you can get to through our website, has the full plans. And when I mean full plans, what I'm saying is I have the PDF files, the files that will interface with most CNC plasma cutters so you can get the shapes cut out, because that was the tricky part. The rest was just welding. And I expect to be using this tooth quite a bit with the time that I have left, because trees, which we have everywhere, like people, can outlive their usefulness. And sometimes it's hard to tell when it's time to take out a tree, and sometimes it's kind of painful. Sometimes it's a project. And sometimes it's hard to tell when we need to make big changes. Maybe there's something we need to do differently or better or stop doing at all, and maybe we could ask a friend, is it time? Or our wife, because she would know. Or best of all, we can ask God. And then when we get our answer, when we know the direction that we need to go, just dig in. Tear it out. Make the change. Thanks for watching Essential Craftsman, and keep up the good work.